Welcome back to part 2 of how to convert improper to mixed using the algorithm. So last time we ended, we were modeling how to take a improper fraction like 10/3 and see it as a mixed number. So here I've written already divided into thirds. If I wanted 10/3, I would shade in 10 of these thirds. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And we remember from last time, hopefully, that we're trying to figure out how many holes do we see? How many are shaded? I see 1 hole is shaded, 2 holes is shaded, 3 holes is shaded. So this is the same as 3 and 1/3. But if you don't have a model, how would you do this? You would use division, because we told you this is a division problem. 10 is being divided by 3. There's a little mnemonic device that we use. We use TIBO, and we talked about this briefly last week. It means top in, bottom out. This is referring to when you're taking this fraction and you're putting it in the division bracket. So on this side, I'm going to put it in the division bracket. The top number, 10, our dividend, will go in the house. And our bottom number, 3, our divisor, will go out of the house. So anytime you hear me say TIBO, that means top in, bottom out. Top number's in, bottom number is out. So then we divide as normal to get our answer. How can 3 go into 0? No. Slide my paper. Can 3 go into 10? Yes. How many times? 3 times. 3 times 3 is 9. I subtract, I get 1. Check. Is 1 less than 3? Yes. Then I slide my paper over. I want a mixed number. I don't want a decimal. I know last week we talked about adding decimal points and zeros, but this time we actually want a remainder of 1. So when you have this as your answer, there's certain pieces or parts that you need to make your mixed number. You need the quotient, you need the remainder, you need the divisor. So you're going to have quotient, remainder over divisor. Our quotient is 3. Our remainder is 1. And our divisor, which is also our original dividend, is 3. That is how you get your 3 and 1/3. Your quotient, your remainder, your divisor. That is how you make a improper to mixed. So you go from fractional form to dividing it in the bracket. Okay? That is your answer. So let's try another one. 9/2. So we know the denominator tells us how to break this up. Each one of these should be broken into 2 pieces. So I'm going to break them into 2 pieces. And then of those 2 pieces, I need to shade in 9 of them. 2, 3, 4, 5, 6, 7, 8, 9. So if we want to change this by model to a mixed number, we're going to say, how many whole pieces do we see? 1 hole, 2 holes, 3 holes, 4. And then I see 1 out of 2. This is 1 out of 2 here. So this is 4.5. If I had a model, I could see 4 whole pieces are shaded and 1 out of 2 is shaded. But if I don't have a model, how do I convert this? I'm going to divide. Again, we're going to use TIBO, top in, bottom out. So my top number, 9, goes inside the division bracket, 2 stays out. We divide as normal, following the division process. How many times can 2 go into 9? Hopefully you said 4. 4 times 2 is 8. I subtract. I have a remainder of 1. Again, I told you last time there are 3 components that you need to make your mixed number. The first component is the quotient. The second is your remainder number. And the third is your original divisor. This is where we can get our 4 and 1/2. Same thing, right? Here we did the algorithm. Here we looked at the model. We got the same thing. Same thing here. 3 and 1/3. So there are 2 ways you can do it. You can model it or you can do the algorithm. You have a choice to do whichever one you think is faster for you. So how do we look at a mixed number and make it improper? So last line we modeled, right? So here we have 2 and 5/6. I've already taken the liberty, and broken this into 6 pieces just to save us a little bit of time on this video. And I know that I'm going to shade in 2 of the holes. And in the last piece, I have to shade 5 out of 6. So then the question is already written there for us. The question is, how many fifths are there? Sorry, how many 6 are there? How many 6 are there? So 1, 6, 2, 3, 4, 5, 6. This is 6, 6. 7, 8, 9, 10, 11, 12, 6. 13, 14, 15, 16, 17, 6. So I have 6 here because the whole thing is shaded, and another 6 here, which makes 12. And if this was shaded, it would have been 18, right? But I'm 1 less. So 17, 6 is the equivalent to 2 and 5, 6. 17, 6 is the improper answer. But if I don't have a model, how do I do this? What do I do? Well, you are going to do the following model. Now, since I moved to Texas and I've been teaching here, I hear some kids call this the Texas model. I'm from Louisiana. We've never called it the Texas model. If it helps you to remember, then great. But if not, this is how you do it. So you're going to go in this direction when you're operating. And there's a plus sign here and a multiplication sign here. That's why kids call it a Texas model, because it's a T and an X, but it's a plus sign and an X. What you do, and I want you to write this out because I've learned over the years, kids make this common misconception about the addition part. You're adding 5 to the product, which is the answer to a multiplication problem, the product of 2 and 6. You're not adding 5 to 2. That is a misconception, okay? So follow along. You're going to write out 6 times 2 equals 12. This 12 comes down to the next line. You add 5 to their product. Plus 5 equals 17. And then your denominator stays the same. This denominator, same denominator. So that's how you get 17, 6. Okay? So I'm going to go through it again in case you missed how you got that. So this is my mixed number, 2 and 5, 6. You multiply 6 times 2. I got 12. I bring that 12 down to the next line. I add 5 to the product, which is 12. 12 plus 5 gives me 17. And my denominator is the same from my original problem, 6. 17, 6. Again, they're the same. They match. Okay? So if you have a model, or if you don't, if you're using the algorithm, it should match. Our next example is 3 and 3/5. Again, I know that I'm going to shade in 3 whole pieces. And in the last section, it should be broken into fifths. And of these, I'm going to shade in 3 out of 5 because that's what 3/5 means. 3 out of 5. So what's our question here? Hopefully you're saying how many fifths? That's the question. How many fifths are there? How many fifths are in this picture? So because this is shaded totally, I know this is 5/5, and this is shaded totally, that's 5/5, and this is shaded totally, that's 5/5. And I only have 3 here, so 3 out of 5. Sorry, my marker is not looking the best. It's not having a sharp point, but hopefully you can tell the difference between a 3 and a 5. This is 5 plus 5 plus 5. 5, 10, 15, 16, 17, 18. So 18 fifths is our answer. 18 fifths would be shaded. If you wanted to go in and you really wanted to see that, pretend my drawing is proportional, that these are evenly divided. You can see 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 fifths here. Okay? So now let's use the other model, how to convert it. It was 3 algorithm, 3 and 3/5. Remember, we go in a clockwise direction. What do we do first? You start here and move clockwise. You're going to say 5 times 3 equals 15. Bring your 15 down. Add 3 to the product of 5 and 3, which is 15. You will get 18. That's your numerator. Our denominator stays the same. So we will have 18 fifths. I hope that this made sense to you guys. And if it did not make sense, please watch this video again. You can go on YouTube and try some other ones so that you have just some more sense being made out of it. I'm going to give you 2 to practice before we end this video. But again, for improper to mixed, T-bow, top in, bottom out, you're going to divide. And from mixed to improper, you're going to use this algorithm, which we're just going to call the Texas method, just so you know what I'm talking about, to change from mixed to improper. So I'm just going to turn my paper over and give you guys 2 problems to try. I would like for you to try 8/3. I don't know what my obsession with thirds is. And I would want you to try 5 3/4. So try changing this with the algorithm, okay? I want you to practice the algorithm because it's faster. If you like the model, you can do both, but I want you to practice the algorithm because it's faster. Change this to a mixed number. Change this to a improper fraction. Pause the video, stop, do this, come back. You got these 2 right, and just to save time, I tossed them on the board real quick so you can look at my work and check your work, but I will walk you through them. So for 8/3, we use T-bow, top in, bottom out, 8 in the house, 3 outside of the house. How many times is 3 going to 8? 2 times. 2 times 3 is 6. I subtract, I get a remainder of 2. Remember, you need your quotient, remainder, and your divisor. I forgot that word for a second. Divisor. So you have 2 and 2/3. And you can go back and check this, right? Because 3 times 2 is 6. 6 plus 2 is 8. You're going to go backwards and forwards and backwards, right? Now that you know how to do it. And 5 3/4. I multiply 4 times 5. I got 20. I brought my 20 down. 20 plus 3 is 23. And my divisor, my denominator stays the same. It is still 4. So 23 divided by 4. Again, you can do this in your head. You know, 4, we're going to 23 5 times because 4 times 5 is 20. You have 3 left over. So this checks out. So I hope that this was helpful to you and you practice. We will definitely need these skills when we start multiplying and dividing fractions. Go out, practice. Good luck.